Can you just throw some light about SVD applications? I mean, the hyperparameters and applications related to SVD for our audience today.
Yeah, thank you, Nitin. Definitely. Yeah, rightly said. Too much of analysis leads to paralysis, right? So that's the very popular caption that we at 360 Digitally use, and Bharani's favorite statement. So when we keep working on various projects, depending on the challenges and depending on the pattern, I should say, in the data, we try to experiment with different algorithms. In some cases, some algorithm works. The exact algorithm may not work in a different kind of a scenario. So we have to keep experimenting, and there is no standard answer that this will work in this case and this will work in this case. That's something that we have to be remembering. As I always say, right, I look at data science as a research study. So, and there is no standard process for researching on things, right? So remember that one. Now, coming to the applications, right? SVD is very, very interesting algorithm because of the way it is designed. It's called as multi-layered algorithm for the fact on how it is designed. It's basically depending on linear algebra, and it uses matrix factorization concepts and all that. Technically, right, we'll discuss these things in our regular sessions. Of course, you can join those sessions or you can view those sessions on YouTube channel to gain more knowledge on that. But the concept is that we are decomposing original data, which is a two-dimensional data, into three different matrices, and then we do approximation. We call it as R approximation or K approximation, which eventually allows us to take only subset of those split data. Now, why I'm explaining this is because the applications perspective, whenever we talk about, let's say, algorithms which deal with personalized data, for example, Netflix, a lot of personalized data is there, right? What movies you watch, when you watch, and all that. Now, Netflix should be very well aware of that the data security clauses have to be implemented, and they cannot share the information about my preferences to anybody else, including even if there is some kind of a hacking happens. It should make life very difficult for the hackers to get the personalized information. So in these kind of cases where data security is very important, you can probably prefer SVD because of its design, right? And this is, one of the applications, and very widely used by Netflix. It is used, as Bharani already mentioned, it is used in Google search, for example. When you do a search, right, you probably give two keywords, for example, data science. Now, when you say data science, let me just write it on my screen otherwise. So these are some of the examples, friends. I was just wanted to show it on the screen. So recommendation engine, this is Netflix example. Image processing, this is very widely used in including your facial recognition algorithms, the autonomous vehicle examples and all that. LSI or LSA, this is where your search engine basically comes into the picture, text related applications. And so on and so forth, genomics and all that is that. Let me use this as an example. Now in Google, let's say you are going to say data science. You're interested and you want to learn data science. So use this keyword, right? So if you look at the text, I have only two words or two tokens. We call them as tokens, right? This has to give me a result which is talking about multiple websites like this, right? So I'll get website 1, website 2, website 3, website 4, so on and so forth. So there are many things that you'll have to look at here. Why is this order coming in the first place? Why not this website coming at the first when you do a Google search? Or why in the first place this website is coming? Now, if you talk about two words and you are trying to map the similarity between a huge content on the website, right? The website will not have only two words, right? It could have huge content, documents and documents, pages together. So how you do a mapping of two keywords with a website content? You cannot just map them, right? And in fact, you're also ranking them. So this is where your LSI SVD concept comes into the picture. Blindly assume that wherever you have high dimensional data, right, you need to apply dimensional reduction concepts. So when I talk about a website, if you can look at the text content, it is a very big content, right? Very big document. When I split all this text document, I get many words, or we call it as tokens, hundreds and thousands of tokens I will get. Now, I cannot compare directly two words with thousands of words. So using SVD, we try to compress these, let's assume, thousands of words into two words. Assume, I mean, logically, this is what happens in the backend. So using SVD, we try to compress the high dimensional data into something which is manageable. Now, once I get two words or two tokens, then I will be able to easily map, right? So logically, SVD is applied for these kind of Google search analysis, and that's nothing but your LSI. A very high level, I'm trying to bring up the point. So mentioning that, right? So these are some of the applications. In short, wherever you have high dimensional data, your dimensional reduction techniques can be applied. There are many friends, right? As Bharani has already shown, there are many techniques, but very popular are these two techniques, which are frequently used in the data science community. Anithan, thank you.
Yeah, thank you. Thank you so much, Sharath. Yeah. So, Bharani, I'd like to ask a very fundamental question here. We have running out of time today. Maybe we can do it at a later point of time. So could you throw some light about factor analysis? Because I think our audience needs to know some fundamentals about factor analysis before we get into the, the hyperparameters. So maybe you could spend about 3-4 minutes factor analysis vis-a-vis ECA and SVD.
Okay. So sorry about that. Yeah. So yep, absolutely. Factor analysis is one of the techniques when it comes to dimension reduction. When it comes to the underlying rationale on why we use factor analysis versus why we use PCA, is simply put, why do you want to take Uber and why not Ola? Right. So the differences are very difficult, right? We do not have a profound way of segregating these two techniques. So we say that factor analysis, dimension or principal component analysis or SVD, all of these are dimension reduction. At the end of the day, they help you reach from one place to another. So given this context, there is no specific use case where only factor analysis should be applied and not the other techniques. Having said that, understanding the concepts of factor analysis will help you understand something called as LDA, latent directly allocation, which is also one of the topic modeling techniques, which is built based on probability values. And this is one of the most famous topic modeling algorithms, which is currently being used in the industry. And it is the best for that case in comparison to LSA or LSI. Okay, and factor analysis works exactly the way principal component analysis works. When it comes to principal component analysis also, if you have 100 inputs, for example, or 100 features, you'll have 100 principal components. In factor analysis also, it would be exactly the same. If you have 100 inputs, then you'll have 100 factors, factor 1, factor 2, so on and so forth. But until and unless we blow life into these new factors or new principal components, they will not make any sense. So if you want those to make sense, you will have to look at what are the values, scores, or what are the principal component scores, values. And then we need to, try hard to give an appropriate name for this. Otherwise, the interpretation part is completely gone. right? And if you're lucky, you'll be able to interpret, but you have to become lucky, right? You cannot leave completely to your luck. You have to somehow figure out what is a logical name that we can give to the factors or principal components so that they start making sense when you use it in your probably supervised learning techniques, such as predictive modeling algorithm, right? So, and also one more thing is when it comes to the hyperparameter, once again, it's the number of components. So number of components is something which is applied in PCA, SVD, factor analysis, etc. And that's one thing which people have to remember. Okay. So.
Yeah, we have a question from Mr. Praveen, which says, so is it based on your selection? I think I can answer that, Praveen. It is not on the whims and fancies of a data scientist that any algorithm, it's not just with reference to dimension reduction, any algorithm that we choose, it is not on the whims and fancies of the data scientist. It is more to do with using multiple algorithms and choosing the one that is suited the best, one that is having a good what shall I say, quality metric is good, one that has explainability. All right, so that is basically the reason. It's not on the whims and fancies. Can you explain how to use cheat sheets after opening it, showing package? Can you, Sharath, can you please take up that question?
Maybe Sharath, you can go to learning resources and maybe just show the learning cheat sheet part.
Yeah,
I think we have to unzip
probably
that.
Stop sharing.
Yeah.
Yeah, let me just try to share the screen. Okay, I think there is some issue on the website. Okay, so yeah, the navigation is correct, Shrikant. There will be there should be some case of issue. I think that is the reason why it is not routing to the packages. Routing to the PDF files. I will get it rectified. You can probably try after 30 minutes or so. You should be able to get the PDF files, .pdf files with respect to all these packages that you are seeing on our screen. For example, this one, you will be getting a zip file on the website. Okay, under the learning resources here, you have cheat sheets, right? Under this, the PDF will be made available. So let me check the status on that. Not sure why it is routing to this. I'll get it rectified.
All right. So thank you so much, Sharath and Bharani, and thank you, audience, for consistently joining. We would definitely wish if the numbers would increase considerably. But yeah, nevertheless, the people who are joining regularly, thank you. And I do hope that the delta increase in the knowledge base is substantial because of this. So please continue to attend these sessions. And we shall connect back tomorrow with some more interesting topics and discussions amongst the three of us. Thank you so much.
Thank you. Thank you.
Yep. Thank you all so much.